You've driven past 1,000 of them. That long silver tube on the highway, shaped like a giant squashed pill, hauling gasoline at 70 miles an hour in the lane next to you. And you never once asked the obvious question. Every other truck on that road is a box. The furniture truck, the Amazon truck, the moving truck, boxes. So why does the one carrying 9,000 gallons of liquid fire get to be a weird metal blob? Here's the answer you're probably reaching for. Round is stronger. It holds pressure better. And you'd be reasonable to think that. But a gasoline tanker barely holds any pressure at all. It's tested to about 3 pounds per square inch, less than the air in a basketball. So if it's not about pressure, what is the shape actually for? The real reason is sitting in your kitchen and your garage right now, and you've never noticed it. This shape is the only thing standing between 30 tons of moving liquid and the car beside you, and it was built that way on purpose, after decades of things going horribly wrong. The answer has 4 parts. Almost nobody hears past the first, but let's start with what everyone gets wrong. Here's the part everyone gets right, at least halfway. Corners are the enemy. When you load any container, the force doesn't spread evenly across a box. It piles up in the corners. A flat wall wants to bow outward, and the sharp edge where 2 walls meet becomes a stress concentrator, a single weak line where cracking begins. A curved wall has no such weak point, and it spreads the load smoothly around the whole surface and converts forces that would bend a flat panel into simple tension, which the metal shrugs off. So a round tank survives what a square tank can't. That part is true. But here's what that misses. A gasoline tanker isn't really fighting pressure. Remember that 3 pounds per square inch? A DOT 406 fuel tank is what engineers call a near-atmospheric vessel, basically an open air container with a lid. So if the shape were only about resisting pressure, you wouldn't need to obsess over it. Which raises the real question. If barely any pressure is involved, why does the round shape matter so much that the entire industry refuses to build a square one? The answer is weight, and it's brutal. To make a square aluminum tank stiff enough to hold 30 tons of sloshing fuel without its flat walls flexing, you'd need an enormous skeleton of bracing and thick reinforcement at every corner. That reinforcement weighs a fortune. And on a fuel truck, weight isn't an inconvenience, it's the entire business. These trucks run right up against federal weight limits, which means every pound of tank is a pound of fuel you're not allowed to carry. A heavier tank permanently shrinks your payload on every trip for the life of the vehicle. The curve isn't a luxury. It's how you get a tank that's strong and light enough to be worth driving. And here's the strange twist. The truly ideal shape isn't a cylinder at all. It's a sphere. A ball gives the most volume for the least material of any shape that exists, which is exactly why it keeps showing up later in this story. But you can't drive a giant ball down the interstate, so engineers reach for the next best thing, a sphere stretched into a tube. That's all a tanker is. But that's only part of the story, because the real reason the shape is squashed, instead of perfectly round, has nothing to do with strength at all. Look at a tanker from behind, and you will notice it is not a circle. It is an oval, an ellipse, wider than it is tall, like someone pressed down on a cylinder with their thumb. That flattening is not for looks. It is there to win a fight against the most dangerous thing about hauling liquid, and the fight has nothing to do with the metal. It is about where the weight sits. A tall, round tank carries its load high. Squash it into a wide ellipse, and the same 9,000 gallons ride lower, dropping the truck's center of gravity toward the road. A lower center of gravity is the difference between a truck that leans through a curve and one that rolls onto its roof. But here's where it gets genuinely strange, because the load you're carrying is alive. Liquid doesn't sit still. When the truck brakes, the fuel lunges forward. When it turns, The fuel climbs the sidewall and tries to keep going. Engineers call it slosh and surge, and it means the center of gravity you carefully lowered is constantly trying to move on you. Now here's the statistic that should rearrange how you see every tanker on the road. According to federal crash data, roughly 90% of tanker rollovers happen when the tank is only partly full. Not full, partly full. A half-empty tanker is more dangerous than a full one, because the empty space is exactly the room the liquid needs to build momentum and throw its weight against the wall. And this connects to something in your kitchen right now. The same math is why the propane tank behind your house is shaped the way it is. But we'll get to that. The surge can hit hard enough to shove a braking truck into an intersection, or flip it sideways at a lateral force of only about 1/3 of gravity. That's not a violent maneuver. That's an off-ramp taken slightly too fast. So the ellipse does double duty, lowering the weight and giving it less height to swing through. But the shape alone cannot tame a living load. So engineers fight it from the inside too. They weld baffles, internal walls with holes, across the barrel to break up the surge and split the tank into 3 to 5 sealed compartments, loaded one at a time, so only a fraction of the fuel is ever free to move. The shape is not one decision. It is a stack of countermeasures against 30 tons of liquid trying to kill the driver. But here's the stranger part. This shape did not come from a whiteboard. It came from a 90-year fight with disaster. Because fuel tankers didn't always look like this. Go back to around 1910, when tank trucks first rolled out for companies like Standard Oil. And the picture is unrecognizable. The tanks were riveted, sheets of steel pinned with thousands of rivets, the way they built battleships. And riveted seams have a fatal flaw when your cargo is gasoline. They leak. Every rivet is a hole, every seam a line of holes holding back a flammable liquid, waiting for a spark. Worse, in a crash, those seams split open like a zipper and dumped raw fuel across the road. So the industry spent 2 decades clawing toward a better joint, and welding replaced riveting through the 1920s and the 1930s. A welded seam is continuous metal, no holes, far less likely to rupture in a wreck. That single change quietly saved an unknowable number of lives. But the real breakthrough came in 1930, when Standard Oil of New York took delivery of the first fully welded aluminum petroleum tank, built by a Milwaukee company called Heil. Aluminum, because it was light. Welded, because it did not leak. That's the moment the modern fuel tanker started to exist. And here's the detail that reframes everything. The shape kept evolving for decades after the problem was technically solved. Heil built the first streamlined tank in 1934, but the elliptical straight barrel design, the exact squashed oval you see today, did not arrive until 1966, with a tank literally named the Challenger. It took half a century of leaks, rollovers, and fires to arrive at that oval. Nobody invented it in an afternoon. It was filed down by failure, one wreck at a time, which means every feature you can see is really a scar. Those raised rails along the top are rollover rails. They're to protect the hatches and valves so they do not shear off and gush fuel when the truck lands on its side. The compartments, the baffles, the squashed oval, none of it is styling. It is everything that once went catastrophically wrong, frozen into metal. Therefore, what you are about to hear should change how you see this shape, because it is not on a truck. It is on almost everything you own. Strip away the fuel and the regulations, and a tanker is just 3 rules made of metal. Curves beat corners. Low weight beats tall weight. The most volume for the least material wins. And once you see those 3 rules, you see them everywhere, in objects you've handled your whole life, and never connected to a gasoline truck. That propane tank behind your house is a stretched cylinder with rounded ends, sitting low for exactly the reasons we covered. The water heater in your closet is round because a square one would bulge and fail at the seams. The The soda can you crushed without thinking is a pressure vessel with walls thinner than a hair, still round, always round. The aerosol can, the fire extinguisher, the scuba tank, everyone curved, everyone refusing to be a box. Go bigger, and you find the submarine, a cylinder with domed ends, because the ocean crushing in from all sides is just pressure, and pressure hates a corner. Even under your own back seat, your car's fuel tank has baffles breaking up the slosh so your gas does not throw the car around when you brake. You've been surrounded by this decision your whole life. You just only noticed it on the one vehicle big enough to make you look. So here's where you land. You pulled up behind that silver tanker thinking you were looking at a weird metal blob, but you were looking at 4 answers stacked into one object. Corners concentrate stress, therefore it can't be square. A square tank strong enough would be too heavy to legally carry a worthwhile load. Therefore it's curved and light. A tall round tank rides dangerously high. Therefore it's squashed into an ellipse to drop its center of gravity. And the liquid inside is alive and trying to roll the truck. Therefore baffles, compartments, and rollover rails. 4 problems, 1 shape, filed down by 90 years of leaks and fires until it became the most optimized object on the entire highway. That boring oval you used to ignore is a rolling argument between physics, weight law, and the simple need to not flip over. You're not looking at a blob. You're looking at a safety device shaped by a century of disaster. And if you think that's strange, wait until we get into why the tanker right behind it, the one hauling milk, is built in a completely different shape on purpose.